morning all. Today I am going to explain today's problem of the day. Find position of a set bit. So let's see the problem once. Like, given a number n having only 1 and all other zeros. In this binary representation, find the position of the only set bit. If there are 0 or more than 1 set bit, the answer would be -1. The position of set bit is 1 should be counted starting with 1 from the LSB side of the binary representation of a number. Okay, so before proceeding to the problem, let me explain you something about the bitwise operations. Okay, so let's go to the dashboard. So what is a bitwise operation? Basically, bitwise operations are the operation which perform on the bits of a number. Like if you are given a number 5, if you are given some number like 5 and 6, so if you perform any of the operation, like let's take the operation OR. Okay, so if you perform operation OR, so what will be the equivalent binary form of 5? That will be like 1 0 1, right? And for 6 it will be like 1 1 0, right? So if you perform the operation OR, bitwise OR, so for each and every bit you have to perform the OR operation. So 1 or 0 is equal to 1, 1 or 0 equal to 1, 1 or 1 equal to 1. So answer will be like your 7, right? So basically this is a bitwise OR. And bitwise, and you know, like if 0 and 1 equal to 0, right? 0 and 0 equal to 0, 1 and 1 equal to 1, right? This is the bitwise AND operation. Okay, so XOR operation. XOR means finding the if there is a same element, like 1 XOR 1 is equal to 0, 0 XOR 0 equal to 0, and 0 XOR 1 equal to 1. If the bits are different, then it will be 1, and if the bits are not equal, then it will be 0, right? This is the XOR operation. And the negation operation. So negation 5, what will be the negation 5? You just flip the bits. Okay, so like for 5 it's equal to 1 0 1, right? So if you flip the bits and you have only 3 bit number, so if you flip the bit, what will be the number? 0 1 0, right? That will be your 2, right? Negation 5 equal to 2, right? Okay, so last two thing is left shift and right shift. So what is the left shift? Like you are given a number n and you have to shift this number to the left. Okay, this number bits to the left. Like for example, you are given 5, right? Your bits are like 1 0 1, right? So if you do left shift by 3, okay, so what it will do, it will append 2 zeros in the back. Okay, sorry, 3 zeros in the back. Okay, so it will move it to the 3 position to the left. So like what will be the value? 1 0 1. Okay, it will move to the 3 positions, right? So 0 0. Okay, so first position, if it move first position 0, right? Like if it is move the first position, then it will be like 1 0 is coming, then again 1 0 coming, again 1 0, means 3 times it will do the shifting in the left side. So answer will be this one. This one is equal to like 8 plus 16 32, right? So answer will be 40. Okay, so if you shift 5 with like in the left shift, if you shift the 5 with 3 bits, then your answer will be 40. Similarly, the right shift means you have to move, suppose you have 0 0, okay, 0, so you have to move it to the move this bit to the right 3 times, right? So if you move this bit to the right 3 times, what will be the answer? 101. All the 3 bits will vanish, right? Vanish. So this is all like the bitwise operation which we required in day-to-day, means in day-to-day problem solving, right? Okay, so we have read that questions, and right now I'm going to explain how to do that. Okay, so for finding set bit means for there is an example like 2 given they are given number 2, right? So what will be the binary form of this one? 1 0, right? So set bit means the bit is equal to 1. Okay, so like if there is an set bit we have to find, right? So what we can do, 2 is there, right? Okay, so we can modulo it with 2, or we can we can do an operation with 1. So we get either the bit is set in the leftmost part or not. So what we will get if we do AND 0 1, and we will get 0 0, right? So if it is 0, that means this bit is not set, right? This part, okay, this bit not set. So if it is not set, our count would not increment the values, right? After that, what we will gonna do, we gonna right shift this value by 1 bit. Okay, we gonna right shift this value by 1 bit. So after doing the right shift by 1, what we will get? 1, right? So 1 and 1, if you do that, you will get 1, right? So your count will be like 1, right? And again if you do the right shift, then it will be 0, right? So we have to do the same operation, means all the operation which I am telling you, shifting the bits and doing AND with 1, okay, to get either the rightmost bit is a set bit or not. Okay, so like you have to do until your number is greater than 0. Okay, your number is greater than 0. Okay, so here you get a count of 1, right? In which position you get a count of 1? Okay, so you have to store the index also. So every time you shift, you just increment, you just store a index I equal to 1, and every time you shift the value, you just increment that I. Okay, so you get the index. So you just store the index, make a variable index and store this value I. Okay, and if you and one more problem is there, if there is two set bit, then also you should return -1. So in this case there is only one set bit, right? For 2, right? For 2 there is only one set bit. So you just need to return the index, right? Index of set bit. But in case of 5, if you see the 5 0 1 0, right? In case of 5, so you can see 2 set bit, right? This one and this one. So when you are doing this operation, the first step is to check with the number first of all you have to AND this number with 1, and you have to check whether this equal to 1 or not. Okay, if it is equal to 1, then you just increment the count. Okay, increment the count, and you just you have to store the index also, index equal to I. Okay, and then second thing what you have to do, you have to shift that N with in the rightmost right shift. You have to do the right shift of that N by position 1, right? So you have to make N equal to N right shifted by 1, right? Okay, okay, and then you have to increment your I to get either this is because of to finding index, right? If there is a possible answer. So the thing is, like, there may be in this case you will get 2 count equal to 2, right? Because 2 set bit is there, count equal to 2. Okay, so in this case also you have to find return -1 to the answer. Okay, you have to return the -1 to the answer. Okay, so let's see the code. So as I told you, I have initialized count is equal to 0 and index equal to -1. Either there may be a possibilities like there may be some possibilities like 0 0 0 means your number is given 0, right? So if you find index equal to -1, then that means your number is 0, means it is not entering the loop, which I have shown here. N equal to greater than 0. Okay, n greater than 0. So if it is 0, the number n is given 0, then it will not enter. That means your index value is -1. So in this case also you have to return what? -1, right? You have to return -1. So like then what we have to do, like I have stored I. Okay, I in the sense to count the index, right? So to find the index of that part, if there is a possible answer. Okay, then what I do, I just told you that like I do AND operation with 1, and if I get AND means the rightmost bit is set, right? So I have to do the count plus plus, and I just update my index. Okay, and then what we have to do, we have to right shift it to with 1 bit, and then I just need to increment I. Okay, so if my count is not equal to 1, you just return -1, otherwise you just return the index. So I think I have submit that. I think it's clear to you. I have submit that. You can see the correct answer. Okay, thank you. Please like share and subscribe my channel. Okay, bye. Thank you.